So I'd like to, address each of these components in turn and provide a little more detail. The concept of real estate supply is not commonly used in other kinds of models. Typically, people just talk about land use, whereas in Cubeplan, we really divide it into real estate supply and the demand for real estate, which is the households and firms. But the supply side is really representing the built environment, meaning space for sale. This includes physical buildings plus land that can be occupied by households or firms or jobs, which are basically just a result of taking firms and multiplying them by their size to get the total number of jobs in all the firms in an area. We count real estate supply using real estate units. So one housing unit, for example, is occupied by one household. That's sort of the definition of a housing unit. And one non-residential unit is occupied by, let's say, one firm, although we could allocate jobs directly if we chose to structure our model that way. And these are grouped by real estate type. So for example, we can cluster different kinds of land use or real estate supply into lot size and floor space categories, which may in turn be related to more aggregate zoning categories such as residential, high, medium, low density, industrial, commercial, et cetera, et cetera. And the description of the attributes of these real estate supply types can also be aggregate. So we might have average characteristics by zone or area type with general relationships such as the floor area ratio, which is the ratio of built floor space to total land consumption for a given property. So this is a really flexible way of describing land use in a way that's disconnected or allows us to be general about what kinds of households or firms or jobs might locate in a particular type of real estate supply. So then the next question is using the bid rent function inside this model to relate consumer willingness to pay for that real estate property once we've described it to characteristics of the property itself, meaning the lot size, the floor space, other characteristics that are specific to that type of real estate, the neighborhood, or in the case of our travel models, this usually means the zone in which this real estate property is located. And so these characteristics include accessibility, for example, which is a transport model derived attribute of the neighborhood for a particular zone, as well as other schools and shops nearby. So we can look at the effects of intrazonal capture on the attractiveness of a particular area, because certain areas become much more attractive when you don't even have to go out on the roadway network to access schools and shops, for example. And we can also look at the attributes of the consumer, such as income and lifestyle for households. Household size is one aspect of lifestyle. Married, unmarried, with kids, without kids is another way of looking at it. And we can look at aspects of the consumer related to the industry of a firm or a job that might affect where they prefer to locate. And all of this is related to the fundamental, very sound and proven and tested and well understood bid rent theory, which goes back to Alonso's work in 1964 and is graphically depicted here. The idea is that these bid rent functions, or these bid functions rather, create different curves relating attractiveness or willing to pay for some real estate property to these different characteristics. So in this simplified model of the city where accessibility goes down as you get further and further away from the CBD, we have accessibility affects the bid function for retail, manufacturing, and residential in different ways, and that's represented by the slopes of these different curves. The highest willingness to pay wins the auction of a particular piece of real estate, and so we see retail concentrating in the center of the city here, manufacturing outside of that, and then residential outside of that. And this graphic, I should give credit, comes from Wikipedia's entry on this theory. So different types of uses will compete for land in various locations, and the bid function quantifies these trade-offs between values, which then naturally result in a given pattern of land use throughout an urban region. Cubeplan has, as I mentioned, a very flexible method of treating transport's effects on land use, and this is one side of the land use transportation connection. Household and firm bid functions, as I mentioned, include transportation service quality parameters or measures. For households, this includes accessibility, ease of access to desirable destinations in the region, and for firms or jobs, this includes attractiveness or ease with which customers or other businesses that supply inputs to the industry can access the place of business. So accessibility is outward-looking and attractiveness and inward-looking, but both can be market segment specific. So meaning different households, for example, of different income levels or different sizes, might have very different accessibility measures or perceptions of accessibility by location. And different firms might have different perceptions of accessibility and attractiveness by industry category because they require different inputs, meaning different labor from different sectors of the workforce, or they might require being proximate or close to industries of different kinds. So each industry, each different kind of firm or household has a slightly different accessibility and attractiveness sort of curve when it looks out at the region around it. And CubeLand takes all of this into account. It also takes into account interactions between consumers and suppliers inside this sort of overall solution for an equilibrium between demand and supply. So we have this big feedback loop from demand to supply using what's called a rent model. The rent model takes all of the bids or willingness to pay for a particular real estate type in a particular location and aggregates those together to get the expected willingness to pay, which is the rent that you can expect to receive from a consumer if you go out and sell a piece of real estate in a particular location. And the supply model tries to model the choices made by developers and in general providers of real estate as far as which kinds of real estate they're going to provide, which kinds of housing units and which kinds of non-residential units or commercial floor space, etc., to produce and how much of each kind. And both of these are sort of discrete choice models, but the idea is that we feed back inside the location choices people make and inside the developer choices to take into account the fact that one household's location decision is going to have effects on other households and how they locate, because it might be the case that certain households want to be close to another household of a particular type or the same type and might want to be further away from another household of another type or of some particular type. The same thing for industries. Like I mentioned previously, certain industries want to be close to each other, other industries don't need to be close to each other or would rather not be close to each other. So this creates these complex economies of scale and location externalities that can be incorporated in CubeLand within this equilibrium loop. And overall, basically what CubeLand is computing is a solution to equilibrium and this entire location system. It's a fixed point problem which we model as a system of dependent nonlinear equations. And really what Francisco Martinez and his team have contributed is a highly efficient solution approach. It's very fast, very efficient, and an equilibrium exists for a real range of scale parameters, which we programmed into the software. The uniqueness is confirmed via numerical search. So we have confirmed via numerical search that this provides a unique equilibrium. And I won't go into the details of all the math. It's very scary and Greek-looking. But basically suffice to say that we have a feedback process with looping and iterative solution of the problem until we achieve a real estate market equilibrium. And this is part, of course, of a bigger equilibrium between the land use side of things and the transportation side of things with feedback in between the two. So the output data sets, whether or not you understand everything that's going on inside the model, you can understand what it gives you. And that includes things like the number of real estate properties, i.e. housing units, by type in each zone, market rents for each type of housing unit by type and zone, which are a kind of simulated real estate price or property value, if you wish. It gives you some ability to measure the economic impacts of our land use and transportation policies, actually, and look at things like housing affordability and jobs housing balance. We can also look at the built area by type of use in each zone, and we get households and jobs by zone location and real estate property type, as well as bids of each consumer type on each real estate property type and zone. So in addition to the winning bids and the actual outcome of the auction that we're simulating, we get the losing bids too, which households and jobs didn't wind up being located there and why. So there's a lot of opportunity to really dig into the process and understand the fundamental underlying dynamics of the real estate market in each local area. And one of the things that this provides, for those of us who are interested, and you may be looking at this for reasons of forecasting things like the value of time, which is a critical factor in willingness to pay for such facilities as toll roads and transit systems that charge a fare. And so we can get the average household income by zone as well as the full income distribution by zone from CubeLand. And one way to use CubeLand is just as a more rigorous or more robust way to forecast socioeconomic inputs that in the past have simply been previously assumed based upon present-day distribution of these kinds of values. So I'd like to do a little demonstration now, interactively using the Cubetown 5.1 model. And I want to mention that this model is available on our website at any time. And the exercises I'm going to quickly show you are also detailed in a tutorial we have on our website. So let me just go to my web browser here, and you can see I'm at the page citylabs.com tutorials.html, which is accessible by going to our home page and then going to the bar at the top of the page and going to support and tutorials. And you see here we have a tutorial on Cube Voyager called Discover Cube 5.0. That's used with this Cubetown demo model, which you can download from the download link below under Demo Models. And then we have Discover Cube Land, which is just a little PDF tutorial that walks you through some of the exercises I'm just going to discuss now. So if you're interested in evaluating CubeLand, we do have step-by-step procedures for how to run through a simplified model and understand some of the inputs and outputs of the model. So I'm just going to briefly give you a brief guided tour of how this model works. Here we have our Cubetown demonstration model, and in this model we have our scenario pane on the left-hand side, of course. And we also have our application manager open. So the idea here is in the scenarios pane, we track and manage a hierarchical list of scenarios where we have branching behavior, where a set of scenarios branches off from our base case, and then we have growth scenarios that then can be spun off. And each scenario is derived from some scenario you've previously run. So when you create additional scenarios, the attributes are sort of cascaded through this hierarchy in a logical fashion. And we have this data manager that allows quick and easy access to a fixed set of inputs and outputs, as well as some reports for every single scenario. So you click on a scenario here and then click on the reports to get access. And then down in the application pane, this is our demonstration model, so it includes all kinds of different demonstration models. The one I have open right now in the application manager flowchart view is the land use transport interaction Cubetown demonstration model, which is essentially the same as our Cube Voyager passenger travel demand forecasting model, with the exception of the addition of a Cube Land demonstration model inside the four-step modeling process. So we can tell from the execution order that this precedes trip generation directly and is a part of the feedback loop with congested costs occurring from assignment to the demand model. And the idea here is that we take the prior values of the level of service output by the assignment model here, coming out of this feedback loop here, where we take assignment, we do an AM peak assignment to get congested costs, and then that's copied over for the next iteration and sent to the CubeLand demonstration model, as well as the trip distribution and mode choice models. Now inside the CubeLand demonstration model, we convert this level of service matrix into accessibility measures that are then used inside CubeLand. We also bring in control totals that specify for each agent type, and we've set up a whole range of agent types here. In this case, we have a total of 50 agent types in this model corresponding to different income categories and size categories of households, as well as different industry categories and size categories for firms. And we have attributes of each of these types of agents, in addition to the number of agents locating within the study area or the region.